how is FeatureForm different from, let's say, other players in feature store industry now?
Yeah, that's a great question. And I think it comes down to like understanding like the different types of feature stores that are out there, and even understanding why like a virtual feature store is maybe just a terrible name for what feature form is. Like category wise, it's very like not it's very not descriptive. Okay, so the three types of feature stores, and interestingly, they kind of roughly correspond also to I think the waves of MLOps too, of like how like different paradigms in the tools have developed. So the three types are the literal, physical, and the virtual. So let's talk about like the literal, because I think everyone understands that intuitively. Uh, a literal feature store is just literally a feature store. It will store the features, both the definitions and the values, and then it will serve the features. That's kind of pretty much all it does. It's like a very special. It's almost like a very specialized like data storage solution. Um, so, for example, an example of that would be Feast. Feast is a Feast is a literal feature store. Um, and that it's a very lightweight option. You know, you can also implement it very easily. Implementation risk is low, right? Because you're essentially not, there's no transformation, there's no orchestration or computation going on.
This was surprising. So why it's lightweight? I understand that literal feature store stores features, so it's kind of replace your storage, right?
Yeah, well, so when I say lightweight, I mean like if you find implementing Postgres, like that kind of lightweight. So technically it's not super lightweight. But if we put on a spectrum compared to like a physical feature store, so a physical feature store is like it has everything. It stores features, it serves them, but it also will orchestrate and do the transformations. It a lot of times, so the physical feature store, that is very, very like a heavyweight, and that's why I think of on a spectrum in terms of both like implementation and maintenance, and administration.
So on the spectrum, the physical is the heaviest.
Yes, absolutely.
Literal, like the transformations are done somewhere else and saved
Yes,
back to literal. Okay.
yes,
And the feature store itself is it's just a library, right? The feature store, first of all, feature store is just a library, right? Which is basically performing actions against storage, correct?
yes. Well, yes. Literal feature store. Well, that's almost like an implementation detail, but yeah, like for the most part, like Feast, for example, is a library. And they provide you with different like providers, right? So you
can
do have a
configure it
choice.
against yeah, you can configure
Yeah.
it against S3, against DynamoDB, against Redis, right?
Yeah.
And the
Absolutely. Absolutely.
lightweightness comes, I guess, from it being just a thin library on top of this storage, and you manage the
100%.
storage yourself, right?
So there
100%.
is
Yep.
no backend, there is no component
There
that stores
there
metadata about this feature store.
well, the literal feature store, all it does in a way is just store features and like metadata. It won't actually do any of like the heavy lifting of the transformation or the orchestration,
So what is
right?
then virtual? Because I got
Yeah.
what is physical. This is
Yeah.
quite clear. But
Yep.
curious, what is virtual then?
Yeah, so the virtual feature store paradigm, we kind of try to take the best of like both worlds. So something to say, like there is a use case for the different types of feature stores, right? Like the physical feature stores, they came out of companies like Uber, like Twitter, like Airbnb. They were solving like really gnarly problems when it came to like processing like huge amounts of data in like a streaming fashion. So, but the challenge is with like, so the physical feature stores, you're pretty locked down to like your provider or the provider they choose. You can't actually swap out. For example, if you wanted to use Cassandra, Redis, versus like as your what we call like the inference store or the online store, uh, you can't actually do that usually with a physical feature store. Usually a physical one, you kind of just take whatever providers they give you. So it's almost like another like specialized like like a data processing and storage solution. So with the virtual feature store, we try to take the flexibility of like a literal feature store where you can essentially like swap out providers. You can use BigQuery, you can use like you can use BigQuery, you can use like AWS, you can use like Azure. If you want to use different inference stores, you've got that. But what we do is we focus on what we think are like the actual problems that like feature stores are meant to solve, which is not just versioning, not just documentation and metadata management, and not just serving, but also like the orchestration of transformations. So for example, with FeatureForm, like we do this because we are Kubernetes native, right? So we're assuming that data scientists, for the most part, don't want to write transformations elsewhere. They probably want to be able to do stuff like they normally would do with like Python, with SQL, with like Spark flavor, like PySpark with data frames. So we assume they want to do that. They just want to be able to like, for example, like wrap their like features in like a decorator style or like write it as a class style if they want to. And they kind of like shouldn't have to do the infrastructure side. Like they shouldn't have to provide all this fancy configuration and have to like figure out what the path to production is. And so we try to also make that like as streamlined and simple as possible. The idea is that you have a new data scientist that joins the team, and like everyone's experienced this, right? Like you go to a new company and you basically just spend like the first 3 months trying to look for like documentation in Confluence. You're like reading people's like Slack channels to be like, what exactly did they do with this like forecasting and like churn project? You're hunting down the data. You find out that the queries are broken and you're like, God, what were they thinking about this? And then like a leader comes to you and they're like, oh yeah, by the way, like the numbers are wrong. You gave me these numbers and they've changed. And you're like, oh shoot, now I need like lineage. Oh god, I need to track. Oh, and then the part that really hurts a lot of enterprises right now is regulation. So in Europe, that's in any company that does business in Europe, right? It's GDPR is a big one. But a lot of medical companies in the US, for example, they're under HIPAA, which is for medical and like health companies. Uh, so for a lot of them, they have to like oddly enough, lawyers are very involved in the ML process. Most people don't realize this. But in the enterprise space, like lawyers are the ones who, like, for example, they get a lawsuit or new regulation comes out and they need to go like, okay, can I like track what features are being used in what models? So those kinds of like workflows are the things that like we're really trying to solve with the virtual feature store paradigm. It's just like making sure that when a data scientist is doing feature engineering, which is like the most heavy and intensive part of the data science process, they don't have to go to all these different places, learn new languages, when like the feature engineering part is already like so hard.
So, Miki, if I may, so from I will look at that from two perspectives. From maybe administrator perspective, somebody who'd, let's say we are going to deploy virtual feature store in as part of our tech stack. So I need to have storage like S3 or BigQuery, as you said. I would need to have infrastructure to perform computations. It can be a cluster run by Kubernetes, maybe something else. Anyway, virtual feature store is an abstraction on top of storage and compute component.
Yeah. So we actually, I did a talk at Data Council and we had released what we thought was like, we call it a market map, but that's not actually quite correct. So we had actually kind of released a diagram of what we think is like the ML stack, like architecture. So the way we look at it is like, okay, so you have a computation storage, right? Which is just things that run across like every team. These are not like what we call like layer 0, layer 1. These are not necessarily like ML concerns because you need computation storage, right, to like run an e-commerce website. So we'll use that an e-commerce website as an example, right? Then the layer above that is when you have like the providers, or for example, for a lot of folks, like if you're a solo data scientist, maybe you just need access to like GPUs for machine learning models. Maybe you really like to use like Spark, and you have your other serving providers. So at that part, that's where we start seeing like a little bit of the differentiation for like ML problems. Underneath that, you might also have like Kubernetes, right? Because that also might be doing the orchestration for the full company. So the virtual feature store like goes above your like Spark and Ray and your like Databricks offering, for example. Now above that though, like, and we're seeing this now with like, for example, the mid-size space. There's a lot of folks who've been publishing like amazing descriptions of their like ML system. So for example, Shopify published a blog post about Merlin. There's like a few other folks. I think DoorDash has also published some really good stuff. Now people are also starting to look at what we call these like unified MLOps frameworks. And that's where you have like, for example, like your ZenML. There's a few others that are like in that top layer. But yeah, so the virtual feature store would actually fit in between like your unified MLOps framework and then your actual like providers like Databricks, Spark, all that. And then below that would be like Kubernetes and Ray.